Okay, good morning, students. So today we'll do the miscellaneous solved example of determinants first. So now let me explain that how we are going to simplify these problems. Now, this is the problem, the example 30. A, B, C are positive and unequal. That is, A is not equal to B, is not equal to C, and they all are positive also. तो हमें इसको नेगेटिव प्रूव करना. We have to prove that it is negative. Now, what I am doing here, applying this operation. So delta will be equal to A plus B plus C plus B plus C. It is B, C, C, A, A, B. Now taking common A plus B plus C. Now this may be like this. 1, 1, 1, B, C, A, C, A, B. Now let us make two zeros here. R2 minus R1 on R3, R3 minus R1. It is 0, C minus B, A minus C, A minus B and B minus C. Now expanding along C1. We will be having minus B minus C whole square minus, it is something like this. Now if we open it, it will be A plus B plus C minus B square minus C square plus 2BC minus A square and minus now see what is that minus minus plus AC and plus AB and then minus BC. So we will be having A plus B plus C and minus A square minus B square minus C square plus BC plus AC plus AB. Now see, can we write this as, हमने multiply and divide by 2, we will be having 2A square 2B square plus 2C square 2BC 2CA 2AB, now which is equal to minus half A plus B plus C and which is nothing but A minus B whole square plus B minus C whole square plus C minus A whole square. Now see, A is positive, B is positive, C is positive, so therefore this sum is also positive and this is perfect square, this is also positive, so hence this quantity is negative. So this proves the question. Now we'll do the next part. Now see what is the next part. Here ABC are given in AP. If ABC are in AP, then obviously we can say that this B is A plus C by 2, or you can say that 2B is equal to A plus C. This is the first thing they have given. Now you might observe one thing here carefully. If I add row 1 and row 3, it is nothing but you can say that twice of the second row. Now clearly you can see that their sum is nothing but twice of that. Okay, now what I'm applying here on R2, now see, on R1, if I apply operation R1 plus R3 minus 2 times of R2. Now what you will observe here, now see, it is something like this. It is 0, and it will be 18 plus A plus C minus 18 minus 2B, that is 3y plus 5, 6y plus 8, 9y plus B, 4y plus 6, 7y plus 9, 10y plus C. This will get cancelled with this, and A plus C is again same as this. Now this determinant, the first row become 0, so hence the value of this determinant is 0. Now we have another question, and this question that I'm going to solve is the one of the most important question, and the students, you are required to see the solution carefully, because it is not an easy question, and how we are going to simplify it, just try to see it. Since in the determinant you see that perfect square and the product is up here, so first we are make the all the elements as identical. So on R1 I multiplied by X, R2 if I multiplied by Y, and R3 I multiply by Z. So therefore this delta will be equal to XYZ upon XYZ. So what will happen? It will be X into Y plus Z whole square, X square Y, Z X square, XY square, and Y into X plus Z whole square, and Y square Z, XZ square, YZ square, X plus Y square into Z. Now taking common XYZ from C1, C2, C3 respectively. Taking common XYZ from C1, C2, C3 respectively. So now we will be having also I think we have committed mistake here. It is goes in the next step, that is XYZ by XYZ. It will be Y plus Z whole square, and it will be Y square, it will be Z square, and it will be X square, X plus Z whole square, and Z square, X square, Y square, और X plus Y का whole square आ जाएगा, Now see the next step. Now we have to create a common factor here. Now see how we are going to create. Now I am applying the operation on C2 as C2 minus C1, and on C3 minus C1. Now see what is going to happen. Delta will be equal to y plus z whole square, y square, z square, and it will be x square minus y plus z whole square, x plus z whole square minus y square 0, and x square minus y plus z whole square 0, and x plus y whole square minus z square. Now we can use the formula here, a square minus b square as a minus b and a plus b. So it will become y plus z whole square, y square, z square. We can factorize it like this, x minus y minus z, and x plus y plus z, again x plus z minus y, and x plus y plus z 0, and x minus y minus z, and x plus y plus z 0, and x plus y minus z, and x plus y plus z. Now let us take the common. Taking common x plus y plus z from C2 and C3, it will become like this. So y plus z whole square, y square, z square, and x minus y minus z, and x plus z minus y 0, and x minus y minus z 0, and x plus y minus z. Now this is the crucial step, that how you are going to deal with it. Now see, if you see the pattern of the elements here, again some are squares 1. So what operation I'm going to apply here is really important. देखिए अगर आप R1 को देखेंगे तो इसमें एक पर्टिकुलर एलिमेंट अपीयर हो रहा है, और जिसके बेसिस पे आप जजमेंट निकालेंगे, ये y प्लस जेड का होल स्क्वायर और y स्क्वायर जेड स्क्वायर. तो हम क्या करेंगे, यहाँ पर R1 पे हमने ऑपरेट किया R1 minus R2 plus R3. By applying this operation, I will be having two yz minus 2z minus 2y y square x minus y plus z 0 z square 0 x plus y minus z. Now see, that's what we want to do. Now we can make two zeros on C2 if I apply the operation as C2 plus 1 by y times of C1, and on C3 I apply the operation C3 plus 1 by z times of C1. So our delta will be equal to x plus y plus z whole square, and it will be 2yz 0 0 y square x plus z y square by z z square by y, and x plus y. Now expanding along R1. Expanding along R1. Now what is going to happen? Two yz x plus z multiplied by x plus y minus xy. it will be x plus y plus z whole square 2yz x square plus xy plus zx plus zy and minus xy. This will get cancelled with this. Now from this entire bracket x is common, 2xyz into x plus y plus z. So we will be having 2xyz into x plus y plus z whole cube. So that proves the question proved. So student, it's a really tricky question. So do it at least twice this question. Now this question is again a very famous question. देखिए अगर मैं यहाँ पर मैट्रिक्स ए बनाता हूँ, हमारी मैट्रिक्स ए 1 -1 2 0 2 -3 3 -2 4, और जो सेकंड मैट्रिक्स है, इफ आई टेक दिस एज माय मैट्रिक्स बी -2 0 1 9 2 -3 6 1 -2, and if I take my matrix D as 1 1 2 and matrix X as x y z. Now what you will observe here, as per the direction we have to calculate AB. 0 2 -3 Now when you calculate this product, what you will observe, it will be nothing but -2 -9 plus 12, then 0 -2 plus 2, then 1 plus 3 -4, then 0 plus 18 -18, 0 plus 4 -3, then 0 -6 plus 6, then -6 -18 plus 24, then 0 -4 plus 4, and it is 3 plus 6 and -8. So this is nothing but identity matrix, that is 1 0 0 0 1 0 0 0 1. So what we have observed, that AB is identity matrix. So in this case A inverse is B, so no need to find B here. And system of equations will become AX is equal to D. So X is equal to A inverse of D, and A inverse we have already found it is B. So what we are going to do here, will make use of the B matrix. What is B matrix here? -2 0 1 and 9 2 -3 and 6 1 -2, and the D matrix is 1 1 2. Now simply multiply it, it will give the value of x y z. Now see, it is -2 plus 0 plus 2, then 9 plus 2 -6, then 6 plus 1 -4, that is equal to 0 and 5 and 3. So we have the value of x y z here. X is 0, y is 5 and z is 3. So easily we have done this question. Now see the last question. We have to prove this. Again it's a technical question. So what we are going to do here on the delta, I apply the operation R1 as R1 minus x times of R2. By applying this delta become, because I need to calculate the factor 1 minus x square, it will become a into 1 minus x square, c into 1 minus x square, and p into 1 minus x square. That is ax plus b, cx plus d, px plus q, and uvw. Now taking common 1 minus x square. If I take 1 minus x square as common, then ax plus b, u, c, cx plus d, v, p, px plus q, w. Now then the next step, what I'm going to do on R2 minus x times of R1. If I do this, then I will be having 1 minus x square ACP and BDQ and UVW. This is over RHS. So this proves the question. I hope you must like this video. So please subscribe the channel for the more updates.